Hello, everybody. Welcome to this third webinar of Louis Bellet. First of all, let me introduce myself for the one who don't know me. My name is Hervé Baour, and I'm responsible for global marketing and international sales. So this is the third webinar. We already made two that you can find on our YouTube channel. Today we will talk about gear and hob cutter. Let me show you this. So we will talk about these cutters. They are dedicated for a burr-free gear production. You will be able to learn how our cutters are meant for in order to produce these gears. During the presentation, you will have the opportunity to ask questions. So go ahead in the Q&R section of your interface and just type your question during the presentation when you do have it in mind, and we will answer them at the end of the seminar. We also will do some surveys in order to in order to better know your needs and for which application you do work. And so in order to start with one, I will open the first poll, asking you in which field the wheels that you produce, if you do so, are the gear used. I'll let you some seconds to answer, and we will go on and with a little history of hob cutting or hob cutters production for Louis Bellet. So some years ago, I would say about 20 years now, Louis Bellet was requested to produce some hob cutters, and we tried to find some machines that are available on the market to produce the hobs, precise enough for the request we had from our customers, but we couldn't find any. So we began to produce, design, and mount our own machines. So that was in the late 90s or beginning of 2000, and so it led us to make our homemade machines. They were all here in Vandelancourt, so in the headquarters. But since now 1 year about, we moved them to Burr-free, so our second location. So you might know we have two locations now, one here and one 10 kilometers away from here. And all the hob cutting tools are produced in Burr-free, so in an autonomous way. The modules that we do produce, or the hobs we do produce, are going from 1 down to 0.01. So it's really tiny, really precise, really small. So in terms of DP, for the ones who use diameter pitch, it's 25 to 2,500. So yeah, it's really fine pitch gears. Thank you for having answered the first question. Now we will talk about two challenges you do have while producing your gears. The first one is the burr, of course, and how to remove them. And this leads me to ask you the second poll, and to know what or where are your problems while producing the gears. Is it the burr? Is it the profile geometry, etc.? So I leave you some seconds once again to answer this. So let me share my screen. So burr is typically something that we need to take care of. And one way of removing the burrs on a normal way of hopping is to use insert tools. So you see here a video. I hope you do see the video. So you do produce. This is made on a lathe machine. So you come and plunge. You make the profile of your gear, and then you come with the cutter with the inserts to remove the burr in the front and in the back. This works fairly well. However, the issue you might have is that the burr on the face is removed, but it goes inside of the gear. And this is not what you want to do at the end of the day. So a way to remove this burr or to produce gears without burrs are to use two hubs on a shank or on an arbor. These two cutters are these are not designed but place mounted one tail to the head. So you have two cutter. One is cutting left, and the other one is cutting right. And the standard way is to go from side A to side B. So you plunge, you do the gear production, the gear machining from A to B. So the A side is clean because you are machining it on a climb milling, and afterwards you once arrive to the B side, you have the burrs that goes outside of the gear. So you reverse both rotation, so from the spindle of the tool and from the spindle of the part, you move your assembly with the two hub cutters on the second cutter, and you do plunge towards side B in order to cut the burr which were formed at the B side. What you need to know in order to produce that is that the burrs or the profile of the hub needs to be perfectly aligned with the other one. But doing this might lead to some issue because when you put two hubs on a shank on an arbor, you might have some run out, both axial lateral run out. So it's not easy to mount two hubs on the same shank. So at Louis Bellet, what we propose, and this is what we will talk about now, is the duplex hub cutter. So you can have it as I saw you. Maybe I can show you it once again. So you can have it on a shank, like on the left-hand side, or on a ring on the right-hand side. So you have both cutting edges or cutting zone on the same shank, which leads to a better or a more precise alignment of the two cutting zone. You have you do not have any issue with the alignment, with the run out, because it's made on a monoblock way. And also what really takes you time to produce this or to set up the machine is to really precisely align the helix or the profile of the cutter or of the hub inside the gear itself on the second cutting zone. So here what we do is to have the same helix on the zone A and on the zone B. So you are sure, and you do not need to set up this. You are sure that once you are on zone 2, you are perfectly aligned with the gear part. So it saves you dozens of minutes and sometimes hours in terms of setup. So as you know, time is money, so you save a lot of time and you save a lot of dollar in using that kind of cutter. What I can show you now is a video that we made at our customer. So this is a Tornos machine. We did that at a customer right next door. So the cutter is fairly tiny, so 6 millimeter in diameter, 8 millimeter width, with 2-time pitch in the in between. You have a left and right area, and also it's a module of 0.1, so it's quite small gear that needs to be cut. So as said, the cutter is a duplex, a ring type. The dimension of the cutter, we saw that. We will machine a brass gear. The same cutter actually made a stainless and a brass gear. We did that on a Tornos Evodeco 10. The hob speed, it was 5,000 RPM, and the part, so with a ratio, it was 625. And the feed rate that you can see per teeth is a 2 micron, and on the y-axis is 6 micron of millimeter. So let's have a look at how it looks like. So here we will go ahead with the first part of the gear. So the zone, the first zone. So we make the cut of the gear. Then we stop the spindle. We reverse the rotation sense both on the hub and on the part. And lastly, we come on the second zone. You can see that we are now on the second zone, and we just come up and cut or remove the burr. So this is the part that was made without touching anything, no post-operation. And you can also see that the part is really tiny. It's a 1 millimeter diameter and 0.27 height of geometry. So it's really small. What we also did was to present or simulate a gear hobbing first with only one pass, so without the duplex process. So on the left hand side you see the part with the burr. So you see, even though it's small, the burr is really there, and there are a lot. And doing the second pass, so the second cutting zone, you see on the right hand side the part which was cut. So once again, no post process. It's clean, geometry was perfect, and the customer was really excited about it. What I can make now is to change the video. So it's really tiny. I put a ruler on the side. So these are millimeter. The big one is the millimeter, and the small one is a half of a millimeter. So you see that. Yeah, I try to put more lights. You see, it's really tiny, but the shape, the geometry is really perfect. And I can also show you the cutter we use to make it, to produce it. So it's a duplex one. Up. Yeah. So you see both region, left cut and right cut. I ask you the last questionnaire, asking you which kind of material do you machine with the hob you are using. So the first one is inox stainless. Second is laiton, is brass, steel, beryllium, copper, and aluminum. So as I said before, I do have it here, but it's really small. You cannot see it, or you barely see it. But I do have a second part which was made in stainless steel with the same hob cutter, it works also outstandingly. What I wanted to say, yes, is from the experience of our customer, they said, we went with a colleague of mine to make the movie to film the machining. So we arrived with the cutter, and the person was really experienced. So he knew he already did a dual gear hobbing, but without our duplex tool. So he had the two cutters. So we arrived and we said, hello, we want to make the video. And he said to us, okay, do you come back tomorrow? We said, no, we have to do it today because we do not have time, much more time. And he said, well, I'm not sure it's gonna work, so please go ahead and grab a coffee and come back in a while. So we went to grab a coffee, 10 minutes, we came back, and he said, it's amazing. I never experienced that. So he could mount the cutter on the machine, on a Torrance machine, Swissless machine, mount it, machine setup, and the first part was good. I mean, he was completely amazed. He never saw that before. So he told us, I mean, usually it takes hours to make the setup of the, already to put the balls, hobs on an arbor, and then you need to set up with the synchronization, or to be sure that the profile of the second hub is exactly perfectly aligned with the gear. So yeah, he was really surprised that it was so easy. So yeah, that was the little story behind it. What I can also mention, I go back and share my screen again. What I can also tell you is, of course, we are specialized in the smaller hubs or smaller finer pitches, but we need to say that we also produce duplex hub cutters with larger profiles. So the one you do see here on the screen was a module of 0.635, 635, or DP40. It was 24 millimeters in diameter, 2 times 22 millimeters of hub cutting, so left hand side and right hand side. And on each side you see the control hub, so you can, it's easier to set up the run out. And the bore diameter was 8. So we really can do any type of dimension. Should you want to have a smaller region for the deburring parts, or for the zone 2, well, on that particular, so on a ring, it's easy because you can just switch it, and you have the complete part for doing the deburring and the gear cutting. But of course, if you are using a double or a duplex cutter, hop cutter on a shank, we might make the second region smaller for the deburring. Okay, so I think I come slowly to the end before going to the Q&A, to the question and answer. Let me check if I do have a question. Okay, so I will begin with the first one. What, talking about the price, what is the price of such cutter? Let's go directly to where it hurts then. No, so let's get back and think about when you do it on a normal way. So when you have to have 2 hubs, you need to pay it twice. Even if it's the same, you need to pay it twice. More or less, when you do use the duplex cutter on a shank or on a ring type, the price of the cutter would be 1.5. It would be for one. So it's so you save you save time in setup and of the machine, and also it costs you less than 2 hop cutters. So it was actually a good question for and easy to answer. Second question, let me check. Can we regrind these hops? That's a good question. Let me go back on this slide here. So you see that this slide is showing you the cutting region. So you have it the front one and the next one. So should you want to regrind it, you come in the middle, directly in the middle, and you go touch on the left and on the right, and you have done the regrinding exactly as you would do on a normal hub. So yes, you can regrind it. It's easy. It's easier on a ring type because you have more space on the back, but you can do it also on a shank type. Shouldn't you have the right tools or the right grinding wheel to make it, you can send us back and we can of course do it for you. Let's go back to the questions. I have 3 more. How do we manage the tilt of the hub while changing the direction? Okay, so we go deeper on the technique. So as I showed you, the helix are the same on both cutting region. So you have the helix angle, but as you do turn or you do reverse the rotation of both the cutter and the part, you do not need to have to change anything on the tilt position. So you don't have to do anything but putting the right helix angle that are mentioned on the design or the drawing that we will send you, and you do first operation, second operation, and then it's clear. So no need to change anything on the tilt, on the angle of your hop cutter. What about hub grinding of duplex hub? Our hub are grinded on both sides. Yes. So once again, if you need to think that both hubs are working on the opposite way. So you see on the here, so on the first region on the right hand side of the cone of the dove, this will cut like this. So the cutter will cut counterclockwise, and on the back it will cut clockwise. So if you want, they are both grinded. They are sharp on both sides, and but you cannot do the vice versa. So you cannot use the cutter on one way on the other way from the same zone. I hope it was a clear answer. The third question, or the fifth question: can each row teeth give same profile? Yes, they are all the same profile. So you can we call that shifting. So you can cut the part on one region of the. Let's say if you use this on a cutting region like this, you use this to make the gear. When you see it's becoming wear, when it becomes to have wear, you just shift to another zone, and you do it again until you come to the end of your region of or cutting area. But yes, all the teeth of one zone, and actually on the other zone as well, have exactly the same profile. Okay, yes, I do not see any question, but you might have some more to come. I just have another one. Can coated hub Need coating all time after regrinding. Ah, okay. Um, no. Usually, what we do is if the hob is coated, we do it will be coated all over, and each time you do regrind, it will remove the coating only where you do regrind. But usually we don't send it to the regrinding anymore. Again, with the all the profile will be coated, but really on the face, the cutting face, you won't have the coating. But usually that's how we do. Um, okay, so I leave you also some time to ask further more questions, but I wanted to share with you the poll that we did. So about the industry you are working in, or where the hubs or the gears are used. So 58%, sorry, are used in the aerospace. 50% in the medical, 42% in the automotive. Then there are other watch industry and dental. Okay, it's interesting to see that aerospace is big for you. What are the problem you encounter with the gear production? Okay, so that's clear. 9 out of 10, so 90% tells me that you do have a problem with burrs and profile geometry. So okay, so you are really exactly on this on the right spot. So using our duplex cutter will solve the burr like this. I mean, right away. Then you do have the axial run out, axial and radial run out. Yep. So here as well, you, no need to care about it. Just to have as it would be just one hop cutting tool. So really good for you. And profile geometry was also one issue. The material that you are cutting. So once again, excuse me for not having translated the materials, but apparently you did get it. So most of you are cutting steel and stainless steel. Okay, and then brass and aluminum, and then finally beryllium copper. All right. Oh, I have many more questions. Good. So is there a process for setting the deburring hub accurately on the back face? HMS on the center line of the hub. Well, as I tried to explain, the profile is or the helix angle is exactly the same on both side of the cutter. So that means if you have the two cutting region, so one and two, one and two, you do cut the gear on the one, you go there, you go there. Any way on the second area, you will be synchronized and perfectly aligned with your gear. So no worry about that. As they are monoblock, they were grounded exactly on the same machine at the same time. You do not need to care about it. It's like you would be shifting in a way. Just you do the shift, but reversing both axes or spindle. So really no worry about getting wrong geometry or not being aligned. You will be you will be automatically. What is the difference between positive rack and negative rack angle of hub? Well, I mean, the cutting gauges are made on one way, if you want. So the angle on the back of the cutting gauge is the same as the one on the front, and identically on the back side as well. So if you do have the V like this for the both grinding, it will be the same angle. However, as it is a logarithmic rake, you don't need to care about these angles in the back. So they are the same rake angle on the front and on the back. Okay, I think I made the most of it. What I wanted also to share with you for the one who don't have my information. So don't hesitate to contact me or info@lbsa for any kind of question or request. We are there for you. You might also find a lot of information on our website. Don't hesitate also to follow us on our various social medias like LinkedIn. You also do have the YouTube channels. I hope everything was great for you. I wish you good luck, good health. Don't hesitate to contact me, and good machining. All right. Thank you. Bye-bye.